When you picture a dangerous volcano, you probably imagine a towering inferno of fire and ash. But a far deadlier threat to humanity might look exactly like this deceptively quiet, snow-capped mountain peak. Slow-moving rivers of orange lava look dramatic, but they are highly predictable. You can literally walk away from them. The true danger of a volcano does not scale with the height of its mountain or the sheer volume of glowing lava it spills. Real volcanic risk is determined by a specific set of variables. It requires complex, gas-rich magma that traps immense pressure, a history of sudden explosive eruptions, and, crucially, extreme proximity to massive human populations. This global map shows the 16 decade volcanoes. Geologists identified these specific peaks because they combine those exact variables. Notice how they aren't isolated in remote wilderness. They sit directly against heavily populated coastlines and major urban centers. Millions of people wake up, commute, and go to sleep every day within the blast zones of these 16 threats. Because they are active, a future eruption is a geological certainty. The relevant question is no longer if they will erupt, but whether humanity will be ready when they do. We know what happens when a city ignores a restless mountain. In AD 79, Mount Vesuvius buried the thriving Roman cities of Pompeii and Herculaneum under meters of blistering ash in a matter of hours. But Vesuvius is not ancient history. Look at the modern scapescape of Naples today. Over 3 million people live directly inside the volcano's red zone, tightly packed into a dense maze of high-rise apartments and narrow streets. Mexico's Popocatépetl behaves similarly, building unstable lava domes that can collapse without warning. This sends 500-degree-Celsius clouds of rock racing down the slopes faster than a highway car, reaching neighborhoods in 5 to 10 minutes. When the arrival time is measured in single-digit minutes, the primary danger immediately shifts from the geology to the logistics. Moving 3 million people through a city's exit routes becomes a mathematical impossibility on that time frame. Some threats mask their danger behind beautiful geography. The tall volcano in the Philippines is deceptively small, but sits directly inside a massive crater lake. This cross-section shows the mechanics of that hidden danger. When rising, superheated magma hits the blue water layer, that liquid instantly flashes into steam. This creates a phreatomagmatic explosion, a violent physical reaction driven entirely by rapidly expanding vapor. That high-pressure reaction shatters the magma into fine, jagged ash and sends destructive shockwaves outward. Within hours, rapid ashfall can blanket the surrounding province and completely paralyze nearby Metro Manila. A massive body of water forces a standard volcanic vent to behave like a pressurized bomb, turning a localized event into a regional catastrophe. In the United States, the single highest volcanic threat belongs to Mount Rainier. Its danger lies in the 130 square kilometers of glacial ice clinging to its steep peak. That ice creates the potential for a lahar, a lethal volcanic mudflow. If localized magma warms the mountain, that ice melts rapidly. Or if a steep slope fails under its own weight, it mixes with loose rock and dirt, creating a fast-moving, concrete-like slurry. Lahars can travel down mountain valleys at 80 kilometers per hour. And the old river valleys originally carved by ancient lahars are now heavily populated suburbs connecting Seattle and Tacoma. When a traditional flood recedes, the water drains away. When a lahar stops moving, it instantly hardens and encases everything, buildings, bridges, and highways, under meters of solid rock and mud. Mount Rainier behaves differently than a classic volcano. A slope failure can trigger a wall of mud today without a single puff of smoke, hitting communities that never saw an eruption coming. With megacities built near explosive vents, steam bombs sitting in lakes, and mud flows that trigger without warning, how do we prevent catastrophic loss of life? The defense relies on a dedicated global network of volcano observatories. These institutions operate as our frontline watchmen, collecting constant data to decode the internal movements of these sleeping giants. Long before magma breaches the surface, it forces the surrounding rock to expand. Geologists track microscopic ground deformation and record the faint seismic tremors that shudder through the crust as pressurized fluids push upward. Observatories translate that invisible data into strict civil defense protocols. For Vesuvius, climbing tremor frequency and gas output dictates specific alert levels, telling local authorities exactly when to execute mass evacuations. This map displays the Mount Rainier Lahar detection system. A network of seismometers and tripwires line the vulnerable drainages. Mudflow vibrations trigger these nodes sequentially, buying emergency centers 40 to 60 minutes of warning time to clear the towns below. We cannot stop the Earth's crust from fracturing, and we cannot freeze the magma moving beneath our feet. But through continuous monitoring, we have moved from blind vulnerability to a calculated early warning defense.